Hi, Elise. Sorry that this is coming so late, and I should have done the videos earlier. I just haven't had the time, so I'm going to make you one big video with all of the self-checks in here, 9.1 through 9.4. Feel free to pause the video whenever you need to pause it, and if something still doesn't make sense, please let me know and I can make a bigger, better video for you. Let me start off by saying that your mother is totally right. The sine, cosine, and tangent stuff usually doesn't happen until SM2 because of the way that this course was set up. There wasn't too much to put in your honors lesson, so I wanted to make sure that what I did put in your honors lesson was a part of the honors SM1, but also I added a little bit of SM2 because I knew you were going to try and get into that SM2 for next school year, and you might as well kind of get a head start on it a little bit. So let's get started with 9.1. 9.1 is all about like finding component forms of vectors and finding like we can call them the polar form. You don't need to really know that it's called polar form, but there's two different ways to write vectors. One is in an x comma y situation, and then the other is in a magnitude comma direction situation. So actually, let me get started by saying this. A vector is something that has magnitude and direction. So magnitude meaning like how long it is, and then direction meaning where it points. A vector in a real world situation would be something like, let me think. If I drive from my house to the grocery store, I drive 3 miles north. So the 3 miles is my magnitude. That's how far I have to drive. And then because I said that word north, that's the direction I'm driving. If I just said I had to drive 3 miles to the grocery store, then it wouldn't be considered it wouldn't be considered a vector because it doesn't have a direction. So, that's what a vector is. That's great. So for these first two examples on the lesson 9.1 examples, currently we have two different points, and we want to create, and those points we want to create a vector with. Now, in order to create that vector, we're going to use this top equation right there, where you have the 2 points x1 comma y1, x2 comma y2, and the formula is just x2 minus x1 and y2 minus y1. When you do that, that shows you what your the component form of your vector, of your overall vector, will be. So my vector we want to be PQ, and when we have a vector we write it with a little arrow on the top just so it shows that it's a vector. And we know that this is x1 and this is y1, this is x2 and this is y2. Sorry, I'm going to zoom in a little bit so that I don't have to write really tiny. So then in my formula, we know it's x2 minus x1, which in this case would give you 8 minus 5, and then y2 minus y1, which would be 8 minus 3. And so when we simplify that, 8 minus 5 is 3, and then 8 minus 3 is 5. So there we have it, and we write vectors with little like V brackets. So my vector PQ would be 3 comma 5. So that's the component form of my vector, which is great. And then the other thing that we have to do on these questions is also find the magnitude and direction. So to find the magnitude and direction, we're going to use these two formulas. The magnitudes one is easy. It's just the square root of x squared plus y squared, where the x and the y are coming from the vector we just found. So to find the magnitude in this case, I'm going to do the square root of my x squared, which is 3 squared, plus my y squared, which is 5 squared. Notice that I put it in parentheses. Make sure that you put anything in parentheses just because the squared, if it's negative, the squared, you want to affect the negative as well. So when I simplify that, I'm going to end up with the square root of 9 plus 25, which is the same thing as saying the square root of 36, which is 6. So my magnitude is 6. And then the last thing we have to do is find the direction, which is what are we going to use that bottom equation that I have written down. So my direction equation is the first time that we use the sine, cosine, or tangent. And I'm going to show you how to do this on Desmos. Now you can do it on a regular graphing calculator as well if you'd prefer to use a graphing calculator. If you want to use Desmos though, that's totally fine too. Let me show you. So first, let's plug everything in we know. So I'm going to say d is equal to tangent inverse, and that tangent inverse is just a function that we do to it. It's kind of like square rooting something. You can take the tangent of something, or tangent inverse. That little -1 sign means inverse. Now all of this stuff, like what tangent, sine, and cosine really mean, are going to be introduced to you in SM2, like your mom said. I'm just showing you some formulas that you can use them with. So then the y is the y from your magnitude, which is 5, and then we've got the x, which is 3. So really we want to find the tangent inverse of 5 over 3. So I'm going to go to my Desmos. Actually, let me pull up Desmos right here. Okay, so on Desmos, and you'll be able to find these buttons on your graphing calculator as well. You want to go to functions right there, or if you're doing it on a computer, usually it has like FUNC. And if you look at the bottom of this page, it has inverse trig functions. So I'm going to click on this tan with the -1. And then we're going to do 5 divided by 3. And then it gives us an answer. Now let me make sure. I just want to triple check that this is in the right. 1 second. I want to triple check that it's in the right. Radians or degrees. You know what? I'm going to just double check it on my graphing calculator. Give me 1 sec. Sorry about this, Elise. Here we go. Tangent inverse 5 over 3. See, that is not in it. Okay, give me 1 second to change this to Oh, here we go. Degrees. Okay, so, sorry, and that's the other thing you're going to learn in SM2. There's 2 different ways to measure an angle in radians or degrees. We want to have everything in degree mode. So, obviously, I hope you saw what I just did. So you can click on this little tool set button, and then on the bottom you have radians and degrees. Make sure degrees is highlighted. On your computer, if you're doing it, the degrees will be kind of like at the top of the keyboard. It'll say RAD or DEG. Make sure the DEG is the one that's highlighted. So in this case, my answer is 59.03 or 04 when we round. So my answer would be 59.04. Let me pull this back up. So I know the direction is 59.04 degrees. So my magnitude is that, my direction is that, and those are my answers. And that, again, is just telling you how long the vector is and then where it points. Okay, so then let's do the same thing for this example too. So I'm going to start with my formula. Let me zoom back up. The formula would be, for AB, we're going to have AB with the arrow on top is x2, which is -4, minus x1, which is 5, y2, which is 7, minus y1, which is -10. The first thing I noticed that you got 2 negatives right here, so I'm going to make it a positive. And then we're going to simplify that, so we'd get -9, comma 17. Because it's a vector, I'm going to put it in those V-shaped brackets. -9, comma 17, bracket. There we go. So there is my component form of the vector, and now that I have that, I can find the magnitude and direction. So for magnitude, we are going to use the square root of x squared plus y squared, so it'd be -9 squared plus 17 squared. Those are big numbers, so I'm going to use my calculator. We know it's going to be the square root of 81 plus, I do not know what 17 squared is, 289. And then let's add those things together. So we have the square root of 370, which I don't believe is, we'll simplify. So I'm gonna create a decimal with it. The square root of 370 is 19.24. So my magnitude is 19.24. Great, now let's find the direction using that formula, tangent inverse of x over y. Oh, tangent inverse of, y over x. So my y is 17, my x is -9. Let's plug that into Desmos again. Oh, wrong thing. So get the keyboard back up. You're going to click on the functions and then tangent inverse. Oh, 1 minute. I'm being really silly today. Functions, tangent inverse, and then we're going to have 17 divided by -9, and it gives me negative 62.10. It's totally fine that it's negative. So I know that D is negative. Oh, shoot, I just forgot it. I'm sorry. Negative 62.10. And there's my direction. Okay. So that's how you do it that way. Now for example 3 and example 4, it's asking you just to go backwards. So they gave you the magnitude and direction for these ones, and now you want to convert it back into component form. So to do that, you're using 2 other equations. The first equation is that x is equal to m times cosine of d, and then the second is y is equal to m times sine of d. Now sine and cosine, again, are those functions that your mom was saying that you won't learn until SM2. I'm not going to teach you all the way through what they are, but I am going to show you just how to use them in these formulas. So we know that in the component form of a vector, you're going to have an x and a y, so we have to solve for both of them. For x in this case, we're going to have m, which stands for the magnitude. So that in this case, that's 28. That's always the first number. And then the d stands for direction, and the direction will always have a degree on it. So it'll be 28 cosine of 150. So again, we're going to go back to Desmos and do 28 and then press the functions button. This time I'm going to use the top portion of that because I don't want the -1. Then we're going to just do cosine of 150, and that gives me negative 24.25. So negative 24.25. Then we're going to find our y by doing the exact same thing, but instead of using cosine, I'm going to use sine. So go back to Desmos. Let's see, 28 functions button, but now I'm going to use the sine on the top. 150, and I get 14. So there we have it. Then if I was going to write it in component form, it would be negative, the little v brackets, negative 20.25 comma 14, and that is our answer. Okay. Same deal here. So we're going to use the same formulas. X is equal to 55 times cosine of 332. And then y is equal to 55 times cosine of 332. I'm going to just use my regular calculator on here so I don't get y'all sick by switching up the pages so often. So for the cosine, oh, whoa, what am I doing? This y one should be a sine. So make sure that you're always clear about that. The x's will have the cosine and the y's will have the sine. So for x, 55 cosine of 332, I get 48.56. And then for y with the sine of 332, I get negative 25.82. So the component form of the vector would be 48.56, comma, negative 25.82. So there's my answer there. Okay, so that's how we do the examples for 9.1. If you want to pause the video here, this is a great time to do it. And then we're going to start talking about 9.2. So 9.2 is about how to add vectors. When we add vectors, we're adding... Basically, you can do it a really, really easy way, but I want to show you 2 different ways that you can draw them if you are like really concerned or you've thought more visually about it. So there's 2 ways, the triangle method and then the parallelogram method. Before we do either of those things, I'm just going to, well, actually, let's do the triangle method first. So when we draw vectors, you always start at the origin, and then where the point is where the vector ends. So for example, you have this t vector and u vector on example 1. And for my t vector, I'm just going to start in the middle at the origin of my graph. And then I'm going to find the point -8, 15. Now each of these little dots I'm going to count as 2 just so I didn't have to make a massive graph. So let's see, 2, 4, 6, 8, and then 15, 2, 4, 6, 8, 10, 12, 14, 6. So there would be my -8, 15. Now, because it's a vector, what I'm going to do is draw a line between these 2 points, and then at the end should be an arrow. Now we're going to do point u, or vector u, and again, I'm going to put a point at the center, and then my u vector is at 1, negative 12, so 1, and then 2, 4, 6, 8, 12, so it's right there. Once again, you draw a line, and then there's an arrow. Okay, so basically, for the triangle method, what we're going to do is we're going to take one of these and move it so that the end, how do I say this? So that the end of the arrow starts at the beginning of the other arrow. So I'm going to move this blue arrow, and now I'm going to start the point right here, like at the very end of my red arrow. Now I know from, like, on my original blue arrow, I went over 1 to the right 1 and down 12. So I'm going to do that exact same thing with this new arrow that I start at the tip of my red arrow. So I'm going to go to the right 1 and then down 15, or sorry, down 12, which would put me right here. And then draw my vector. So it should look, I mean, I'm not a great artist, but it should look exactly the same as the other arrow. It's just that I moved it, right? And then what happens is that my resultant vector, or when I add those two vectors, will be from the beginning of my red arrow to the end of my blue arrow. So my green arrow is my answer. Now, in order to find what my green arrow is, all I have to do is count from the origin. Like, what point does my green arrow end at? And it looks like it ends at, let's see, -2, -4, -6, -7, 3. So my answer would be -7, 3. Now, let me show you, because that was the triangle method, and I'll show you again with the next example, but let me show you something else just to double check your answer, or to be like, well, I don't want to draw all that stuff. You can just actually add them. So if you look at it, -8 and 1, those two are both in the x portions of my points. If I added those two things, I'd get -7. And then 15 and -12, if I added those two things, I'd get 3. So you can just add the x's together and then add the y's together, and you'd actually get your answer right off the bat. I do want you to show me at least on some of them. You don't have to do them on all of them. There's 5 for the triangle method and then 5 for the parallelogram method. I want you to at least do 2 of them where you're actually graphing them, so that I can see that you know what you're doing, like how to move the arrows and everything, how to move the vectors. On the other ones, if you just want to finish by adding the x's and adding the y's, that's totally fine with me, because I'm going to just be looking for this answer on those. Okay, so let's do the next example. So again, I'm going to start by graphing. I start on the middle, and then 19 for the first vector, I've got 19, 3. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 19, 3. There's my first vector. And again, not a great artist. Then for my second vector, for vector n, I've got -5, 12. So 2, 4, 5, and then let's see, it's 12. So 2, 4, 6, 8, 10, 12. Here's my second vector. Once again, it doesn't matter which one you use, which one you choose to move. Just make sure that you're moving only one of them. So I'm going to move the red one because it just looks like it's a little bit easier to move. So for the red one, I know from the origin I went over to the left 5 and up 12. So I'm going to start it right at the point of my blue one, and I'm going to go to the left 5, so 1, 5, and then up 12, 2, 4, 6, 8, 10, 12. So it actually ends right there. All right, and then my answer, or my resultant vector, would be from the origin, or from the very beginning of my blue vector to the end of my red vector. So that resultant vector, all we really need to do is find the point where it ends, because we already know it starts at the origin. So to find the point where it ends, it looks like it's at 2, 4, 6, 8, 10, 12, 14, and then 2, 4, 6, 8, 10, 12, 14, 15. Yeah, so 14, 15 would be my answer. And once again, to double check, you add the x's together. 19 and -5 give you 14. And then you add the y's together. 3 and 12 give you 15. That should be my answer. Okay, The next part of this is with the parallelogram method, which is actually very similar. It's just a different way to draw it. So I'm going to start by drawing one of my vectors. My vector t will be red at 18, 15. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and then 15, 2, 4, 6, 8, 10, 12, 14, 15. So there's one vector. Then my next vector is negative 18, 13. So 2, 4, 6, 8, 10, 12, 14, 16, 18. 2, 4, 6, 8, 10, 12, 13. Okay, so I don't think I made this graph big enough for this, but I'm going to try as hard as I can. So for the parallelogram method, what we're going to do is basically you're going to move the blue one so that it's at the end of the red one. So move the blue vector so it's at the end of the red vector. And you're also going to move the red vector so that it's at the end of the blue vector. We are going to go over my words. I'm super sorry. It's going to look a little bit janky. I'm going to start with the blue vector. So I'm going to move that so that it's right here. We know we go 18 backwards and then up 13. So 18 backwards and then up 13. So 2, 4, 6, 8, 10, 12, 13. Again, I'm really sorry that it's just like drawing over words. It should look exactly the same, just kind of shove it up a little bit. Then we're going to do the same thing with the red one. The red one I'm going to just shove up to the end of the blue one. For the red one, we know we went to the right 18 and then up 15. So right 18 and then up 15. 2, 4, 6, 8, 10, 12, 14, 15. And you know you did it right if they match up. Like if they end at the same point. And look at that. It creates a parallelogram. Now, the parallelogram method, the resultant vector would be if I drew a new vector from the very beginning of both of them. So basically from the origin to where the tips meet, which is right above it in this case. But that point is the exact same point. So, or that point where we met is the resultant vector. So we didn't go left or right. In this case, it would be 0. And then we went up, 28. So my resultant vector would be 0, 28. The counting or adding x's, adding y's still works on the parallelogram method. So 18 and negative 18 give me 0. And then 15, 13 give me 28. Okay, one more with this parallelogram method. So let's start with vector m, which is at 5, negative 12. 2, 4, 6, 8, 10, 12. So there's one of them. And then the next one is 20, 3. Oh, that's a lot. 2, 4, 6, 8, 10, 12, 20, and then 3. Okay. Oh, sorry, one sec. Let's go. Okay, here we go. All right. So once again, we're going to move the red one kind of over to the end of the blue one, and we're going to move the blue one over to the end of the red one. I'm going to start with the red one. So I'm going to start right here. I know I go over 5 to the right 5 and then down 12. 2, 4, 6, 8, 10, 12. There we go. And then the blue one, we're going to start at the end of the blue one, and then we're going to go over 20 and up 3. So over 20 and 3. Okay, and then the point ends up being the same. We kind of already knew that. And then that makes a parallelogram. The resultant vector will be from the origin or from where they both start to where they both end, which just cuts the parallelogram in half. So it's that point. That point right there is at 25, negative 9. Once again, you can just add the x's, add the y's. Okay, so the hardest part about this is drawing the graphs, honestly, but everything else, like just adding those x's, adding those y's, should be pretty easy. Okay, now is a good time to stop if you want to pause before you do 9.3. Okay, 9.3 is actually fairly easy in comparison to what we just did because it's scalar multiplication. Now in scalar multiplication, it's very similar to using it like the distributive property. So for this first example, it's asking us to find 3a where the vector a is 3, negative 2. So what we really do is we just multiply each of those vectors by 3. The way I can write it, like I can say that 3a is equal to 3 times 3, and then 3 times -2. I just multiply both chunks by 3 because I want to multiply the entire vector A by 3, which means my final answer would be 9, -6. Okay, that was easy. And now on example 2, super similar, but now they're giving us 2 vectors. We have to multiply both vectors by something and then add them together. So for vector A, we want to do 4A. So I'm going to multiply, we're just going to start with 4A. For 4A, I'd have 4 times 3 and then 4 times -2, which would give me 12 and -8. And then I'm going to, it says -7v. I'm just going to multiply all of the v's by -7. And then instead of subtracting the 2, I'm going to add the 2. So -7v would give me -7 times -12 and -7 times -10. And then that would give me, let's see, 7 times 12, 84, positive 84, because a negative times a negative is a positive. And then 70, because again, negative times a negative is a positive. Now, we want to add those two things together. We don't subtract because we already multiplied that v by the negative. So really, I'm going to have the x's added together, so 12 plus 84, and then -8 plus 70. So my final answer will end up being 96, 62 when I add those together. Okay, awesome. Now, for example 3 and example 4, these are not already in component form. They're in that magnitude and direction form. Oh, I didn't even finish writing the first example is just -7f. Sorry, that was my fault. Okay, so here's the deal. Some of these, for example 3, because you only have one vector, you can get away with not converting it to component form. And all you're going to do is multiply the direction by it, because a scalar does not change the direction at all. It only changes the magnitude. So for this example 3, all we really have to do is do -7 times 22. And then -7 times 22 is -154. So really, my final answer in the magnitude and direction form would be -152, 240, because that direction doesn't change. It will not change with a scalar. The only thing that changes with a scalar is the magnitude. So this is my answer in component form. Let me double check the self-check. Oh, it's asking you to find the component form. And so from there, now we can convert that to component form. To convert that to component form, remember, we're going to use the formulas. X is equal to m times cosine of d, and y is equal to m times sine of d. So for x, I'm going to have x is equal to -152 times cosine of 240, which, when I plug that into my calculator, well, let's see, -152 times cosine 240, that gives me 76. Ooh. And then for y, I would have -152 times sine of 240. So -152 sine 240. If you struggle at all with like plugging it into your calculator or whatever, just let me know and I will make a video of my calculator and show you how to do it. But there you go. So that means my final answer in component form, I'm going to write it up here, would be 76, 131.64. All right. So now that happened. We did it kind of not necessarily a backwards way, but like we found the new magnitude by multiplying by -7 first, and then we converted to component form. Now with example 4, you don't have that luxury because you want to add the two things together. So the first thing I'm going to do is convert both of these to component form using that x equals m times cosine of d, y equals m times sine of d. And then once I do that, then I can multiply by the -3 and add the vectors. So I'm going to start with vector u. For my x, it'd be 6 times cosine of 225. And then for my y, sorry, my iPad's having a panic attack. It would be 6 times sine of 225. Then for my vector v, I'm going to get x is equal to 19 times cosine of 45. And y is equal to 19 times sine of 45. And let me plug those in. So 6 cosine 225. Okay, so then on here, you're going to, this is weird. You get the same answer. It's fine. Negative 4.24 and negative 4.24. Sometimes at specific angles, you get the same thing when you plug in sine or cosine. So don't panic if that happens to you as well. On this one, you get 13.44. I'm just going to triple check that that happens with the sine. Yep. 13.44. So there's the component forms. I haven't done anything to them yet. I didn't give myself enough room, so I'm going to kind of sneak into the bottom of this. So now my new vector u is negative 4.24 comma negative 4.24. Oh, I started writing a 5. And then my new vector v is 13.44 comma 13.44. Now we have to go back and do this part where it's the negative 3u plus v. So now I have to multiply the first one by negative 3. So I'm going to do negative 3 times negative 4.24 comma negative 3 times negative 4.24. Oh, I keep on writing a 5. And then when I do that, negative 3 times negative 4.24 gives me 12.72. So I'm going to have 12.72 comma 12.72 plus 13.44 comma 13.44. So when I add them together, really I'm going to have 12.72 plus 13.44 comma 12.72 plus 13.44. which gives me 26.16 for both of them. So 26.16, oh, sorry, comma 26.16. That is my final vector in component form. So it was a lot of writing, but not terrible math. The biggest thing is that you have to be able to plug them into your calculator. Okay, so that's the end of 9.3. Now let's do 9.4. If you need to pause the video, go ahead and do it now. Okay, so for 9.4, this is unit vectors. So unit vectors basically do this thing where it takes a vector and it breaks them down into like a, how do I want to say this? Something that you can compare. You can't necessarily compare two different vectors unless they're in unit vector form. Now, in order to put something into unit vector form, you just need to use this formula that's right here. So it's x over the square root of x squared plus y squared, and then y over the square root of x squared plus y squared. Remember, or kind of see if you can recognize that the bottom of that is just the magnitude of the magnitude formula. So if it's easier for you to find the magnitude first and then plug it into the formula, that's totally fine with me. So on this first example, we know our x is negative 7. I'd have negative 7 over, and then the square root of negative 7 squared plus 24 squared. And then comma y, which is 24, over the same square root, so negative 7 squared plus 24 squared. Okay, so I'm going to leave the negative 7 up there. We're going to do the square root of negative 7. Let's see, negative 7 squared plus 24 squared, which gives me, like, when you do the square root, you get 25. So my final answer is negative 7 over 25, comma 24 over 25. And I can't simplify that. That's my answer. That's my unit vector. I'm done. Let's do it for the second example. So for the second example, I'm going to have 4 over the square root of 4 squared plus 8 squared, comma 8 over the square root of 4 squared plus 8 squared. Again, I'm going to figure out what 4 squared plus 8 squared is. So that really gives me 4 over the square root of 80 and 8 over the square root of 80. Now the square root of 80 can be simplified. I don't care that you simplify the square root. Really what I want you to do is just be able to set it up like that, and you're good. That's good enough for me. Okay, so for the third and fourth examples, these are in that magnitude and direction form. So you actually already have the magnitude, which is the 3, but you need the x and the y, so you have to convert to the component form first, and then you can just plug everything in like normal. So for component form, remember your formula is x is equal to m times cosine of d, and y is equal to m times sine of d. So then I'd have x is equal to 3 times cosine of 150, and y is equal to 3 times sine of 150. Let's plug that in. So for x, I get negative 2.60, and for y, I get, oh, wrong one. Let's see, 3 sine 150, 1.5. Okay, so then, and we already know the magnitude is 3, so my unit vector is now just negative 2.60, and we can leave it in decimals, totally fine with me, over 3, and then 1.5 over 3. This 1.5 over 3 can simplify to 1 over 2. If you see that, go ahead and simplify it. If you don't see it and forget to simplify, I'm not going to take any points off of it. But really, because I could simplify this one too. Oh wait, let's see, negative 2.6, I typed it in the wrong. To like negative 13 over 15 if I really wanted to, but you can just leave it like this. Okay. Last one, again, this is your magnitude, so that's like what's going to go on the bottom of my fraction, but we need to find our x and y components to be able to put it into that unit vector form. So to do that, I'm going to have x is equal to 24 times sine, cosine of 60, and y is equal to 24 times sine of 60. Let's plug those in, and I get x is equal to 12, and then y is equal to 20.78. Okay, so then my answers would be 12 over 24. Once again, that can simplify to 1/2. You can just leave it like that, though, if you don't see it. And then 20.78 over 24. That is my final answer as a unit vector. Okay, I realized that this was a crazy long video, and I also realized that I went through it really fast. Please let me know if anything doesn't make sense. Let me know if there's any problems with the calculators, and then always feel free to email me with anything. If you want me to like double check something, because I know you can't submit these online like normal, so if you're like, oh Riley, can you just like check these before you actually grade them, I'm more than happy to do that. If you feel like you need more study material before you take the exam, let me know. I'm happy to give it to you. Whatever you need, just let me know. Feel free to email me, and good luck.